As the phrase common factoring suggests, we are looking for factors that are common to both terms, or in this case, two terms. So here we look at the 3 and the 12 and say, oh, you know what? 3 divides both of those, so I'm going to put a 3 out front. I also look at the x squared and the x. These aren't like terms, but they're the variable terms. And I can say, you know what? There's an x in both of those, so I can divide out or factor out an x from both terms. Once I've decided that 3x is my common factor, I will divide both terms by that. So when I divide 3x squared by 3x, the 3's cancel off, and x squared divided by x leaves x. When I divide 12x by 3x, the 12 divided by 3 is 4. Notice we have the minus sign. And x divided by x cancels out, leaving x minus 4. In the next one, we have negative 5t squared and 10t. Looking at the negative 5 and the 10 first, I'm going to factor out negative 5. If there's a negative in front, good idea to take out the negative. Also, we have t squared and t, so I can take a t out of both of those. Once I decide on the things I can take out or factor out, the common factor, then I will divide both terms by that. This is very similar to the first example. So I'll divide negative 5t squared by negative 5t. The negative 5's cancel off. T squared divided by t is just t. And then 10t divided by negative 5t, 10 over negative 5 is negative 2. And t divided by t cancels out, leaving t minus 2. You can always check your answer by expanding. If I were to do this, I should wind up with that. This one is a little bit more complicated because there are 3 terms, no big deal. So we're looking at the negative 4, the negative 20, and the positive 12. I can divide each of those by negative 4. Then looking at x cubed, x squared, and x, I can divide or take out an x from each of those 3, making negative 4x my common factor. Dividing the 3 terms by negative 4x, the first term would leave x squared. The second term would leave 5x. The negative 20 over negative 4 is positive 5, and x squared over x is just x. And 12x over negative 4x is simply negative 3. So there we have that one. This one wasn't on the page, but this one has just a little bit more to it. Looking at the numbers first, hopefully you can see that each of these 3 numbers are divisible by 5. Then let's look at the p in each of these 3. P to the exponent 4, p squared, and p squared. I can divide each of those 3 by p squared. Looking at the q in each of these, I have q cubed, q to the exponent 4, and q. I can divide each of those by q. Once I have that, the first term divided by 5p squared q will be 3. P to the 4th over p squared is p squared. Q cubed over q is q squared. Second term, negative 10 over 5, or divided by 5, is negative 2. P squared over p squared cancels out. Q to the exponent 4 over q leaves q to the exponent 3, or q cubed. And the last term, 25 divided by 5, is 5. P squared divided by p squared is, well, it cancels out. And q over q also cancels out, so we are done. You'll notice that we didn't put p or p to the exponent 0. You could have put p to the exponent 0 and q to the exponent 0 if you wanted to, but basically they just cancel out, leaving the 5 in front. If there was nothing in front, or it was a 1, you would just leave the 1. And that gives basically 3 pretty good examples of common factoring.